Welcome to our Robotics Essentials course, your starting point for understanding and working with real-world robots. In this 5-part series, we'll guide you through the key concepts, tools, and decisions that bring robotic systems to life, from the basics all the way to deployment. We'll start with an introduction to robotics and its role in today's industries. Then in Chapter 2, we'll explore different types of robots and where they're best used. Chapter 3 dives into key specifications, everything from mobility and sensors to power systems. In Chapter 4, we'll help you choose the right robot for your mission. And finally, Chapter 5 walks you through installation, setup, and troubleshooting. Whether you're new to robotics or planning your next project, this course is designed to get you up to speed, clearly, practically, and confidently. Let's get started. Introduction to Robotics, Chapter 1. Robotics is the science and technology of building and using machines called robots. These robots are designed to help us by doing certain tasks, especially the ones that are too dangerous, too repetitive, or require a high level of accuracy. For example, robots can go into places that are unsafe for humans, like disaster zones or deep tunnels. They can also do the same task over and over again, like sorting parts in a factory or inspecting equipment. Some robots are simple and follow basic instructions. Others are much more advanced and can make decisions or adapt to their environment using sensors and software. In short, robotics is about making machines that help people work smarter, safer, and more efficiently. Let's look at some real-world environments where these robots operate. These include industrial facilities where human access is limited, tunnels that require remote inspection, and disaster zones where robots assist first responders. Through visuals and demonstrations, you'll see how these robots provide safety, efficiency, and reliability in critical missions. Robots come in many shapes and forms, each designed for a specific purpose. Let's take a look at the most common types of robots used today. Wheeled robots are the most common and simple. They move using wheels and are ideal for smooth, flat surfaces. You'll often find these robots in warehouses or indoor facilities, delivering items or performing inspections. Tracked robots move using continuous tracks, like a tank. This gives them better grip and stability on rough or uneven ground. Tracked robots are used in search and rescue, bomb disposal, and tunnel inspections where traction is key. Tracked robots are sturdy due to their lower center of gravity that keeps them from tipping over. They can also use additional modifications such as LiDAR and IMUs. Quadruped robots walk on 4 legs, just like animals. This gives them excellent mobility over rocks, stairs, and complex terrain. They're ideal for outdoor patrols, disaster zones, or areas too unstable for wheels or tracks. Many of these quadrupeds answer to emergency calls and tasks at a given notice, excelling at quick responses and completing tasks that are normally unsafe for humans due to being in areas that are out of reach. Drones and UAVs, unmanned aerial vehicles, fly above the ground, providing a bird's-eye view of the environment. Drones are perfect for mapping, surveying, and monitoring large areas quickly, while tethered UAVs offer extended flight times with continuous power supply, ideal for long-duration surveillance or communications relay. Here is a tethered UAV that is used for communications and data collection, providing a wide view of the area for a prolonged amount of time. Humanoid robots mimic human form and movement, designed to work alongside people in complex environments. They excel in tasks requiring dexterity, manipulation, and interaction, such as industrial assembly, customer service, or hazardous environment intervention. To understand how robots work, we need to look at their three essential components: sensors, actuators, and control systems. Sensors are how robots perceive the world, like eyes and ears. They include cameras, LiDAR, ultrasonic rangefinders, and touch sensors, helping the robot detect its surroundings. Actuators are the muscles, motors, servos, and hydraulics that move wheels, legs, arms, or tools, turning commands into physical actions. Control systems are the brain. They process sensor data and tell actuators what to do. These range from simple microcontrollers to advanced systems using AI for autonomous decision-making. Together, these parts let robots sense, think, and act. Robots are becoming vital tools in places where human presence is dangerous, inefficient, or impossible. Today's platforms go beyond mobility. They gather intelligence, support decision-making, and perform high-risk tasks in real time. They're used to assess hazardous areas, conduct surveillance, stream live video and audio, and map unknown terrain. In some missions, robots even inspect or neutralize explosives, keeping people at a safe distance. Let's look at some of the most impactful use cases. First, hazardous environment inspection. In sites like chemical plants, nuclear facilities, or disaster zones, robots detect gas leaks, radiation, or structural damage, keeping workers safe while delivering real-time data. Next, industrial and utility patrols. Robots monitor equipment, detect safety risks, and spot intrusions, running scheduled inspections day or night, often in remote or hard-to-access areas. Finally, search and rescue. After disasters, robots navigate rubble, access confined spaces, and locate survivors using thermal imaging and audio detection, critical when time is short. Even with all the progress in robotics, several core challenges remain. First, power limitations restrict how long a robot can operate, especially for mobile platforms that rely on batteries. Next, real-time decision-making is still difficult. Robots must process large amounts of sensor data and make split-second choices in complex situations. Robots also struggle to adapt to dynamic environments. Things like moving obstacles, shifting terrain, or unexpected human interaction can throw them off course. Overcoming challenges like autonomy, reliability, and mission readiness is critical to real-world success. At Norsat, we're here to guide you through it. Choosing the right robot isn't just about specs. It's about finding the solution that fits your mission, your environment, and your goals. Whether you're looking for robotic platforms, communication systems, or custom solutions, our specialized engineering and sales teams are here to help. We work closely with you to understand your goals and recommend the most suitable options across a full range of specifications, from mobility and payload capacity to power systems, autonomy levels, and environmental durability. But we go beyond product selection. Our team helps you assess environmental and mission-specific needs, such as operating temperature, terrain, or communication constraints. Match hardware with mission profiles, like search and rescue, inspection, or mobile data collection. Integrate payloads and sensors, including LiDAR, thermal cameras, or communication modules, ensuring everything works seamlessly together. Mitigate common challenges, such as power limitations or connectivity issues, with the right combination of hardware, software, and deployment strategies. And if needed, we can support custom configurations to meet your unique operational needs. Whether you're planning a deployment in a harsh environment, need autonomous capabilities, or have tight size and weight constraints, our experts are ready to guide you from concept to implementation. Let us help you make the right choice, because in your mission, reliability matters. You can explore our product lineup anytime by visiting www.norsat.com, where you'll find detailed specs, application guides, and product documentation.